All right, let's get into it. Number 8. The Black Knight Satellite. In 1998, during NASA's STS-88 mission to the International Space Station, astronauts captured photographs of something that had no business being there. Floating in the darkness above Earth was a large, angular black object, metallic in appearance, with a shape unlike any known satellite or piece of equipment. NASA issued an explanation almost immediately. The object, they said, was a thermal blanket lost during the mission. Case closed. Except the story didn't begin in 1998. In 1960, Time magazine reported on a mysterious dark object detected in polar orbit around Earth, moving in ways that confounded the engineers tracking it. A polar orbit of that kind was beyond the verified capability of either the United States or the Soviet Union at that specific point in the space race. Neither nation had reliably placed hardware into that orbital path, yet something was already up there. The trail goes back even further. In 1899, Nikola Tesla reported receiving strange, rhythmic signals from his Colorado Springs laboratory that he believed originated beyond Earth. The object detected in 1960 was later connected to these accounts, and the legend of the Black Knight satellite took shape. An ancient, unidentified object in orbit, watching our planet long before we ever looked back. NASA's thermal blanket explanation covers the photographs from 1998, and most mainstream scientists accept it entirely. But the thermal blanket does not explain the 1960 radar detections, and it does not explain Tesla's signals. Those anomalies predate human spaceflight by decades. Whatever caused them has never received a satisfying official answer. The photographs may show debris. The radar returns and the radio signals are a different matter entirely. Something was apparently in orbit and transmitting before we had the technology to put it there. Number 7. The WOW signal. On August 15, 1977, astronomer Jerry Ehman was working through a paper printout of data collected by Ohio State University's Big Ear radio telescope when a sequence of characters stopped him cold. The signal was so far outside normal background noise that Ehman circled it in red pen and wrote a single word in the margin. Wow. That annotation gave one of science's most enduring mysteries its name. The Big Ear telescope could observe any fixed point in the sky for exactly 72 seconds, before Earth's rotation carried it out of range. The WOW signal lasted precisely that long, meaning it may have continued beyond what the telescope could capture. It arrived at 1420 megahertz, the frequency of hydrogen, the most abundant element in the universe. Scientists theorizing about interstellar communication had long identified that frequency as the most logical channel any civilization would choose, a kind of cosmic common ground. The signal was approximately 30 times stronger than the surrounding background noise, suggesting a powerful and focused source. Its apparent origin was the constellation Sagittarius, near the star group Chi Sagittarii. It bore every characteristic that researchers had predicted an extraterrestrial transmission would carry. It was narrowband, non-terrestrial in origin, and non-solar in character. It matched the predicted profile almost perfectly. Dozens of follow-up observations have been conducted across the decades since, using increasingly powerful instruments. The signal has never recurred. In 2017, astronomer Antonio Paris proposed it had been caused by a passing comet, but the scientific community largely rejected that explanation because comets do not emit focused radio signals at the hydrogen line frequency. The signal remains the strongest candidate for extraterrestrial communication ever recorded. A 72-second burst of energy that arrived once, fit every criterion for contact, and then went permanently silent. Number 6. The repeating fast radio bursts. In 2007, astronomer Duncan Lorimer was reviewing archival data from the Parkes Radio Telescope in New South Wales, Australia, when he identified something extraordinary buried in the records. A burst of radio energy, lasting only a few milliseconds, had registered with a brightness so far above background levels that it was unmistakable. It had come from billions of light years away. The event was named the Lorimer Burst, and it opened a mystery that has only deepened with time. Fast radio bursts, or FRBs, are millisecond duration flashes of radio energy originating from well beyond our galaxy. A single burst can release as much energy as the sun produces over an entire decade, compressed into a fraction of a second. For years after Lorimer's discovery, scientists debated whether FRBs were even real cosmic phenomena or simply instrumental interference. That question was settled in 2016, when researchers pinpointed the repeating burst FRB 121102 to a dwarf galaxy approximately 3 billion light-years from Earth. The repeating bursts are where the mystery sharpens. FRB 180916, tracked by the CHIME telescope in British Columbia, repeats on a cycle of 16.35 days with a consistency that astrophysicists have struggled to account for. FRB 2219-1221A, detected in 2022, pulses internally every 0.2 seconds, the most precisely periodic fast radio burst ever recorded. Natural astrophysical processes can be rhythmic, but rhythms this exact, sustained across billions of light-years, push at the edges of known physics. The leading explanation is magnetars, a class of neutron star with extraordinarily powerful magnetic fields. A 20-20 detection of a magnetar burst within our own galaxy lent significant support to that theory. But periodic patterns like those seen in FRB 180916 remain difficult to fully explain within the magnetar framework, and no single model accounts for all observed behavior. Something in the distant universe is pulsing on a schedule precise enough to set a clock by, and we are still working out whether the mechanism is natural, exotic, or something our physics hasn't named yet. Number 5. The Proxima Centauri signal. In April and May of 2020, the Parkes Radio Telescope in Australia was conducting observations of Proxima Centauri, our nearest stellar neighbor at just 424 light-years from Earth, when it recorded something that caused genuine alarm among the researchers who later reviewed the data. A narrow-band radio signal at 982.02 MHz appeared to originate from the direction of Proxima Centauri. The signal was designated BLC-1 for Breakthrough Listen Candidate 1, and it became the most seriously considered SETI candidate since the WOW signal of 1977. Proxima Centauri is not just a nearby star. It hosts at least one confirmed planet, Proxima Centauri b, orbiting within the star's habitable zone, the range of distances where liquid water could exist on a planetary surface. The signal arrived from that direction at a frequency that drifted in a way consistent with transmission from a moving planet, rather than a fixed Earth-based source. Researchers at Breakthrough Listen, the largest privately funded SETI initiative in history, took it seriously enough to spend months of analysis on it. What made BLC-1 particularly unsettling was its narrowness. Natural astrophysical phenomena produce broadband emissions across a range of frequencies. This signal was tightly focused, the kind of transmission associated with technology rather than stellar physics. It did not repeat in follow-up observations. The team ultimately attributed it to radio frequency interference of human origin, but the specific terrestrial source was never conclusively identified and published. The formal paper explaining the RFI conclusion received considerably less attention than the original discovery. The quiet attribution to interference, without a named source confirmed in peer-reviewed literature, left the question partially open. Researchers continued monitoring Proxima Centauri. The signal has not returned. At 424 light-years away, Proxima Centauri is close enough that a signal originating there would be among the most significant discoveries in human history. BLC-1 almost certainly had a mundane explanation. Almost certainly is not the same as certainly, and that distance between those two phrases is where the unease lives. Number 4. The Anita Antarctic Anomaly. In 2016, scientists analyzing data from NASA's Antarctic Impulsive Transient Antenna experiment, known as ANITA, encountered something that violated the standard model of particle physics in a way they could not explain away. ANITA is a balloon-borne antenna array that floats above the Antarctic ice sheet at high altitude, designed to detect the radio pulses generated when high-energy particles collide with matter. What it detected on multiple occasions appeared to show high-energy particles traveling upward through the Earth, emerging from the ground rather than arriving from space. To understand why this is disturbing, consider what it implies. The Earth is effectively opaque to high-energy cosmic ray particles. At the energies involved in the ANITA detections, particles should be stopped by the bulk of the planet. For a signal to arrive from below the horizon at those energies, it would have to have passed through thousands of kilometers of rock and mantle, which known particles simply cannot do. Yet the radio signatures ANITA recorded were consistent with upward traveling particle showers. The most conventional explanation invokes tau neutrinos, particles that interact so weakly with matter that they can pass through Earth. But the angles of the ANITA detections were steeper than standard neutrino physics comfortably accommodates, and the event rates were higher than models predicted. Physicists from multiple institutions proposed more exotic alternatives, including supersymmetric particles called STAUS, CPT violating neutrino behavior, and interactions involving entirely undiscovered particle species. Some researchers raised the possibility that systematic errors in the analysis, including reflections of cosmic ray signals off the Antarctic ice sheet, could account for some detections. The ANITA team conducted extensive checks. The anomalous events survived those checks and remain in the published literature as unexplained within the standard model. Something came up through the Earth. The planet, which we have always thought of as a shield, may be less opaque to certain things moving through dark space than we assumed. Number 3. The Cold Spot and the Eridanus supervoid. In 2004, cosmologists analyzing data from NASA's Wilkinson Microwave Anisotropy Probe, the WMAP satellite, found a region of the sky that was measurably, statistically wrong. The cosmic microwave background, the faint afterglow of the Big Bang that permeates the entire observable universe, had a cold patch in the direction of the constellation Eridanus, approximately 70 microkelvin cooler than the surrounding radiation. That number sounds small. The implications are not. The CMB cold spot was subsequently confirmed by the European Space Agency's Planck satellite, which mapped the microwave background with greater precision than any instrument before it. The statistical significance of the cold spot sits at roughly 3 sigma, meaning the probability of it arising by chance is very low. In 2015, astronomer Istvan Sapudi and colleagues at the University of Hawaii identified a supervoid in that region of space, a near-empty region of the universe, approximately 1.8 billion light-years across, now considered the largest known void in the cosmos. The supervoid can account for some of the temperature deficit. It cannot account for all of it. Even factoring in the gravitational effects of that vast emptiness on light passing through it, the cold spot remains colder than it should be. Standard cosmological models, built on our best understanding of how the universe evolved from the Big Bang forward, struggle to produce a feature like this through known processes. In 2015, astronomer Rangaram Chari of the California Institute of Technology published an analysis of Planck data suggesting a faint signal consistent with a collision between our universe and a neighboring bubble universe in the early moments after the Big Bang. The paper was careful and qualified. The proposal was extraordinary, a scar left by a collision with another universe, visible today as an anomaly in the oldest light we can observe. The cold spot has not been explained. The supervoid helps, but does not solve it. A billion light-year bruise in the fabric of the observable universe, shaped by something our physics cannot fully name, sits in the southern sky every night, and we have been looking at it for as long as we have had eyes. Number 2. The dark flow. In 2008, astrophysicist Alexander Kashlinsky and his team at NASA's Goddard Space Flight Center published a paper that challenged one of cosmology's most foundational assumptions. By studying the motion of hundreds of galaxy clusters using data from NASA's WMAP satellite, they detected a coherent, large-scale motion that could not be explained by the known distribution of matter within the observable universe. Hundreds of clusters, spread across hundreds of millions of light years, were all drifting in the same direction, toward a region of sky in the constellations of Centaurus and Vela, at speeds on the order of 1,000 kilometers per second, above and beyond normal cosmic expansion. Kashlinsky called it dark flow. The standard model of cosmology holds that on the largest scales, the universe should be roughly uniform. Matter should be distributed without overwhelming preference in any direction, and the random motions of galaxy clusters should average out to zero net drift across a large enough sample. Dark flow violated this expectation in a direct and measurable way. The only mechanism that could produce a coherent motion of that scale and consistency is a massive gravitational source. But the source Kashlinsky's calculations pointed to lay beyond the observable universe, in a region that is causally disconnected from us under accepted physics. In 2010, Kashlinsky extended the survey to approximately 1,400 galaxy clusters and found the same signal. In 2013, a team using data from the ESA's Planck satellite found no evidence for dark flow, and the scientific community was divided. Kashlinsky disputed the Planck team's methodology. In 2015, he published again, reaffirming the original findings with updated analysis. The debate remains unresolved. If dark flow is real, it means something beyond the boundary of everything we can ever observe is reaching across that boundary and pulling on the largest structures in the known universe. Not a signal, not a particle, a gravitational influence from a place we cannot see, cannot reach, and under standard physics should not be able to detect at all. The dark flow may be the first empirical evidence that our universe is not alone, that something immense waits just beyond the horizon of existence, and that it has been exerting its pull on us for longer than the Earth has existed. Number 1. The Great Attractor. In the late 1970s, astronomers studying the velocities of distant galaxy clusters noticed something that the expansion of the universe alone could not explain. Galaxies were moving with an additional component of velocity, a peculiar drift, all oriented toward a specific region of sky. In 1988, a collaboration of 7 astronomers, including Alan Dressler and Sandra Faber, working independently of any single institution, published the analysis that formally identified the source of that drift. They called it the Great Attractor. It is not a metaphor. Something with the gravitational mass of tens of thousands of galaxies is pulling our entire cosmic neighborhood toward it, and it has been doing so for billions of years. The Great Attractor lies approximately 150 to 250 million light-years away, in the direction of the Centaurus and Norma constellations. The Milky Way is moving toward it at roughly 600 kilometers per second, approximately 1.34 million miles per hour. Every star in our galaxy is making this journey. Every planet orbiting every star. Every living thing that has ever existed on any of those worlds has been in motion toward this point since before the Earth formed. And the Great Attractor does not care. It is not approaching us. It is simply there, and gravity is doing what gravity does. What makes this genuinely disturbing is that we cannot see it directly. The Great Attractor lies behind the zone of avoidance, the region of sky obscured by the dust and gas of our own galactic disk. X-ray and radio observations have penetrated the zone of avoidance well enough to identify the Norma cluster, cataloged as Abell 3627, as a major concentration of mass in that region. But Abell 3627 accounts for only a fraction of the gravitational pull required to produce the observed motion. In 2014, Brent Tully and colleagues at the University of Hawaii mapped our local supercluster, naming it Laniakea, 500 million light-years across, containing the mass of 100 million billion suns, and showed that all of it flows toward the same point. The Great Attractor is the drain at the bottom of our cosmic basin, and we are in the water. The Shapley supercluster, roughly 650 million light-years away, may be contributing significantly to the overall gravitational picture. And some researchers now argue that what we call the Great Attractor is simply our local name for a much larger and more complex flow towards structures we are only beginning to map. That possibility does not make it less terrifying. It makes it more so. The thing pulling at us may be larger than we thought, and we are no closer to seeing it clearly. We did not discover the Great Attractor and then begin moving toward it. We have always been moving toward it. Every human being who has ever lived, every civilization that rose and fell on this planet, every moment of recorded history has taken place aboard a galaxy in motion, falling toward something enormous and hidden and silent, concealed behind a curtain of dust that we cannot pull aside. The Great Attractor has not sent a signal. It has not revealed itself. It has simply waited for billions of years with the patience that only something of incomprehensible mass and age can afford, and let gravity speak for it across every light year between us. If you want to see more videos like this, click the video on screen now and make